Dear students, in the last lecture we have studied Newton's first law of motion, inertia and linear momentum. Today we are going to study Newton's second law of motion. From Newton's first law of motion, what you have studied that if we want to change the velocity of the object, then we have to apply force. If you want to move a scooter by 5 meter per second, then you have to apply force, and if you want to increase its speed to 10 meter per second, then you have to apply more force. So you can say for changing the velocity of the object, a force is required. Otherwise, if body is at rest, it will remain at rest. So by the application of force, the linear momentum will change. Why will linear momentum will change? Because the velocity is changing due to the application of force. Now the question arises, how much force is required to change the velocity of the object? To study this concept, to study the magnitude of that force and the direction of that force, Newton gave his second law. What is Newton's second law of motion? This is the law which is used to find the direction and magnitude of force. Now he stated his law accordingly that rate of change of linear momentum is directly proportional to the force applied on the body. Dear students, you can write it as that F is the external force acting on the body. V is the velocity of the object in the direction of force, and let M be the mass of the object. So at that instant, the linear momentum of the body will be P is equal to mv. Now after a small change in time, that is dt, the linear momentum becomes dp, delta p. What is delta p here? It is the change in momentum of a body in time interval dt. Now this can be written as the rate of change of linear momentum. This is delta p by delta t. According to second law of motion, this change in linear momentum is directly proportional to the net force applied. Now change this proportionality sign with a constant and equal to. Here this k is a constant of proportionality and p is momentum. So we can write it as here F is equal to km delta v by delta t. If linear momentum of the object changes uniformly, it means the rate of change, this delta v by delta t, you can write it as acceleration. So you can write F is equal to k into ma. If we choose the system of unit in such a way that the value of k is 1, then the force becomes mass into acceleration. This force changes the velocity of the object and hence changes the acceleration. So now students, you can say if the force increases the velocity of the object, then this force is known as accelerating force, and if it decreases the velocity of the object, then it is known as retarding force. One more thing students here, if the object is moving with constant velocity matlab delta v is equal to 0, there is no change in velocity, it means the acceleration of the object is 0, and if acceleration is 0, then F is equal to m into 0, so this force becomes 0. So you can say no force is required to move a body with uniform velocity because the change in velocity is 0. And one more most important point is accelerating force is always due to the acceleration of the object is always due to the application of external force. Now the question arises here, is force a scalar or a vector quantity? What is its dimensional formula? The force is the product of mass and acceleration, so it is a vector quantity, and you know students, F is equal to ma. M is the dimension of mass and acceleration has lt minus 2. So this is the dimensional formula for force. Now we study the units in which we can measure the force. The force can be measured in two types of unit, that is absolute unit and the gravitational unit of force. Now what is absolute unit of force? The force is said to have the absolute unit if that force produces a unit acceleration in a body of unit mass. So the SI unit, that is absolute unit, is Newton, and you want to know how to define Newton. The force is said to be 1 Newton when an acceleration of 1 meter per second square is produced in a body of mass 1 kilogram. And now the CGS system of unit, what is that? The CGS unit is dyne. The CGS unit of force is dyne. How you can define it? When 1 centimeter per second square acceleration is produced in a body of mass 1 gram, then the unit is known as dyne. Next student, the gravitational unit of force. What is gravitational unit of force? In absolute unit, we have defined that an acceleration of 1 meter per second square is produced. This 1 meter per second square is produced. But in case of gravitational unit, the acceleration equal to acceleration due to gravity is produced. Due to the involvement of gravity, we call it the gravitational unit of force. And the first gravitational unit of force is the kilogram weight, or you can say kilogram force. The kilogram force, it is defined as the force which produces an acceleration of 9.8 meter per second square in a body of 1 kilogram. And similarly, in CGS system, it is gram weight or gram force. How you can define it? Gram weight is gram force, that is equal to 980 dyne. When an acceleration of 980 centimeter per second square is produced in a body of mass 1 gram. Now in this way you can define the CGS SI unit under the absolute system and kilogram weight and gram weight in the gravitational units of force. Now in the last class I have told you students how to resolve the component, how to write any physical quantity in terms of component along x, y and z axis. I have told you that here I, j and k are the unit vectors which represent the direction along x, y and z axis respectively. Now represent the force in as F is equal to Fxi, the magnitude Fx along x-axis, Fyj and Fzk. Similarly, write the value of linear momentum and acceleration. Put these values in the formula of force, that F is equal to dp by dt. We can write it as F is equal to dps pxi, pyj, pzk. And now you can replace here this px as m into ax. So you can write it as fx is equal to dp by dx, and that is also equal to m into ax. What is ax here is the acceleration along x-axis. You can conclude from here, if you are applying a force along x-axis, then the object will move along x-axis. So this is the significance of this equation. Now one question arises here: what is the use of resolving the quantity in components? Suppose, dear students, you are having the force along x-axis and velocity at an angle theta. Suppose this is the angle made by velocity and force is along x-axis. So you have to find the acceleration along the direction of force. So you can resolve this velocity in two components, that is v sine theta along y-axis and v cos theta along x-axis. So this resolution of component can help you to find the component of velocity along the direction of force. From this, if you have resolved the force, you can write the equation as F is equal to max along x-axis, may along y-axis and maz along z-axis. It means acceleration will be produced in that direction only in which the force is applied. Now we discuss the cases which are based on the second law of motion. Dear student, as you have F is equal to ma, you have the formula m into delta v by delta t. We consider case 1. What is case 1? Case 1 is if you have dv by dt as a constant. It means there is no change in velocity and the object is moving with uniform velocity. In that case, this becomes a constant quantity and F is directly proportional to m. What do you mean by this? If we have a heavy and a light moving object with same velocity, then what you have to do? In order to stop them in same time, we have to apply more force on the heavy body. For example, if you are considering a car and you are considering a bicycle, and in same time you want to stop the two objects, then what you have to do? You have to apply more force to stop the car as compared to the bicycle. So from this case, you can conclude that to stop a heavy body, more force is required as compared to the light body. Then next case, if you take mass and time as constant, if you have mass and time as constant, then what you have? F is equal to m dv by dt, and you have taken mass as constant, delta t as constant. You have the equation force is directly proportional to change in velocity. It means if you are applying more force, then there is a more change in velocity, whether you are accelerating the object or you are retarding the object. It means in a given time, for to move a body by higher velocity, you have to apply more force. The next case, if you have this equation, and in this equation if you assume in next case that delta p is constant, in the next case you have considered delta p as constant. In this equation, dear student, you can have this relation that force is inversely proportional to time. It means if you have more time in happening of any event, then force applied will be less, and if you have less time, then you have to apply more force. Suppose you have a distance of 10 meters and you have to stop the vehicle, you have to apply brake. The distance is 10 meter is much more to apply the brake, so you have to apply less force to stop the vehicle in 10-meter distance. But if you want to stop the vehicle in a distance of 2 meter, 3 meter, then you have to apply more force. So dear students, if the time interval is more, then you have to apply less force. And on the basis of this event only, then we have one application, one daily life example. Then you people, while playing cricket, when you try to catch the ball, you lower your hand, because the lowering of hand increases the time duration in catching the ball, and that time duration decreases the force, hence you are less injured. So this concept is related to the impulse. Now what is impulse? When force is applied on the body for a short interval of time, the last point you have studied that F is inversely proportional to delta T. Okay students, and then you take it F into dt, the time, the force applied for a small interval of time. This term is given a name, that is impulse. So you can define it as the impulse is the force applied on a body for short interval of time, and this effort produced is known as impulse. Mathematically, it is the product of force and time. Its SI unit is Newton second, and it is a vector quantity. This momentum, this impulse is equal to the change in momentum. You have the relation from here. I is equal to F into dt, F is equal to dp by dt. Put the value here and you have impulse is equal to change in momentum. This is known as impulse momentum theorem. This is known as impulse momentum theorem. What is impulse momentum theorem? When force is applied on the object and for a short duration of time, then it is equal to the change of momentum. This is known as impulse momentum theorem. In this way, dear student, we can have the importance of Newton's second law of motion. Many more examples are also there for defining the impulse, that a cricket player lowers his hand while catching a ball, or a person falling on the cemented floor gets injured, but a person falling on a heap of sand is not injured, because when he is falling on the heap of sand, it takes time to touch the floor. Then the force affecting the person is less. Or the huge damage to the moving train takes place when it suddenly collides against a stationary train. That is also the application of impulse. Now student, after studying the impulse momentum theorem and Newton's second law, then we comes to the Newton's third law of motion. What is Newton's third law of motion? It is a common observation that when a body A exerts some force on another body B, then body B also exerts some force on body A. Let us understand with the help of an example. When a player kicks a football, the football moves forward and the foot of the player moves backward. And hence we can say two forces are acting on the body. One, the force applied by the foot on the ball, and second, the force applied by the ball on the foot. These two forces are equal and opposite and are given the name action force and the reaction force. One more thing students, these two forces are equal and opposite but never cancel each other. Why this is so? the forces cancel each other when they are acting on the same body. But when equal and opposite forces are acting on different bodies, they can never cancel each other. Hence, in Newton's third law of motion, the forces are equal and opposite but never cancel each other. These forces always act in pair. So, this is the mathematical form of Newton's third law of motion, that FAB is the force on A due to B and FBA is force on object B due to A. According to Newton's third law, we can write FAB is equal to minus FBA, where the negative sign indicates the direction of force. Now, next is the conservation of linear momentum. What is the conservation of linear momentum? How the momentum is conserved during the study of Newton's third law of motion or the application of force. According to this law of conservation of linear momentum, the total linear momentum of an isolated system remains constant. It means the total linear momentum of a system remains constant if the net external force acting on the system is 0. Net external force acting on the system 0 means if the forces are acting on the object. Let me explain first. Suppose this is the body and you are applying one force here and another force here, then these two forces are equal and opposite, then net external force is 0. It means at that time the momentum of the object is constant. For this, consider two bodies A and B with initial linear momentum PA and PB, and let these two bodies collide for a very short interval of time, that is delta t. After collision, what happens? These two bodies get separated and have their momentum PA dash and PB dash. This, when they collide, what happens? The body B applies a force on body A, and simultaneously the second body is also affected by, this is A. Second body is also affected by body A. Now, according to Newton's third law of motion, FAB is equal to minus FBA, and you have the formula that multiply both sides by delta t, because the multiplication on both sides does not affect the result. So you have delta PA is equal to delta PB. Why? Because this is the impulse momentum theorem. This impulse is equal to the change in momentum. This is delta PA is equal to delta PB. This negative sign is only for the opposite direction. So put the value of this is the impulse momentum theorem, F into delta T, F into delta T. This is the change in momentum of first body, and this is the change in momentum of second body. Now what is the change in momentum of first body? Suppose that initial momentum is PA, final momentum is PA dash. Now what is the change in momentum of first body? This is PA dash minus PA, and similarly for the second body. Now this is equation 1, and from this equation 1 we have the relation that this impulse momentum theorem is having the value impulse is equal to the change in momentum, and hence rearrange the values. You have the momentum before the collision is equal to the momentum after the collision. Hence you can say the total linear momentum of the system is conserved. Now, the example of conservation of linear momentum. The example of conservation of linear momentum is recoiling of gun. What is recoiling of a gun? Dear student, you have observed many times that when a gun is loaded with a bullet, then it is considered to be as a system. The system is consisting of two parts, the gun and the bullet. But when you fire a shot, what happens? Then bullets get separated from the gun. Then it is divided into two parts. The system is now having two parts that are separate one. So consider that capital M is the mass of gun, small m is the mass of bullet. Initial velocity of this system is 0. Initial velocity of system means the gun including the bullet that is at rest. It means the before firing the total momentum of the system is 0. But when you fire a shot, what happens? The both gun and the bullet, they move with different velocities, and that velocities are small v for the bullet and capital V for the gun. So the initial momentum of the system becomes 0 because the gun is initially at rest, and final momentum is the momentum of the gun and the momentum of the bullet. Now you know, according to the law of conservation of linear momentum, the momentum after firing should be equal to the momentum before firing. So put it equal to 0, and now if we rearrange them, then we have the velocity of gun as minus mv, that is the momentum of bullet, divided by the mass of the gun. This velocity is with negative sign. It means it moves in the opposite direction, and this movement of gun in the opposite direction during the shot and bullet move in forward direction, that is known as the recoiling of gun, the recoil velocity of